All right, well, good day, everybody. I'm Amy Lambert, EA's Director of Communications, and welcome to this, our second in our series of webinars as part of our 50th anniversary celebration. Now, I'd like to introduce today's speakers, who will be discussing the use of sediment placement as a nature-based solution to improve resilience. Dr. Dan Walker holds joint positions as a senior geologist with EA and as the Associate Director of the University of Maryland Center for Technology and Systems Management. Dr. Walker has held senior positions with the National Academies of Science, Engineering, and Medicine, the White House Office of Science and Technology Policy, and NOAA's Climate Program Office. Dan is currently a co-author of the Coastal Effects Chapter of the 5th National Climate Assessment, which is due out this fall. A founding member and chair of ASCE's Committee on Adaptation to a Changing Climate, Dan also serves as the co-chair of the ASCE NOAA Task Force on Climate Resilient Infrastructure. Chris Overcash is a senior engineer and EA's Climate and Coastal Adaptation Group leader with more than 26 years of progressive industry experience. His expertise involves the planning, execution, design, and management of projects in marine environments related to climate change, coastal resilience, dredging, and resource management. Chris is also a program manager, instructor, and faculty member of the Johns Hopkins University's Environmental Engineering, Science, and Management programs. And finally, with 23 years of multidisciplinary experience relating to ecosystem restoration projects, Sam Whiten serves as EA's Director and National Service Line Program Manager for Coastal Resilience. Sam serves as a principal investigator for EA's research efforts supporting the U.S. Army Corps of Engineers Engineering with Nature program, as well as providing support to other federal partners such as NOAA, the U.S. Fish and Wildlife Service, and the National Park Service. Now, I'd like to turn this over to Dan to start our presentation.
Thank you, Amy. Can you still hear me?
I can.
All right. Again, thanks for that nice introduction. Thanks to everybody for joining us today. I have the distinguished responsibility here of trying to kind of set the stage. And I think because a lot of the discussion we're going to be talking about is focused on nature-based solutions in the coastal zone, it's appropriate to start with a couple iconic figures. On the left is sea level rise. I'm sure many of you are familiar with this figure. There's always a couple things I like to point out. First of all, we see this long-term trend in sea level rise going back as far as the 1920s. What the other part of it, though, that I'd like to point out is that you see the sawtooth pattern where it seems like there's a lot of variability, especially around the US curve, which is in black. And that basically represents really what we're seeing in this curve is two processes. One is sea level rise due to the melting of continental glaciers, which contribute additional water to the ocean basins of the world. The other is the thermal expansion or the steric effects that are associated with warming. And that's where that sawtooth pattern comes in. If you looked at the temperature curve for the US, you'd see a similar pattern. And I think what's important there is it kind of underscores the fact that when you're dealing with a sea level rise at a particular location, it's a combination of what's going on globally as well as local effects. So for example, sea level rise in the Gulf Coast of recent years has been much faster than on the Pacific or Atlantic coasts because the Gulf Coast is a shallower basin. It's warmed disproportionately. Therefore, you get more expansion, more sea level rise. So we have a fairly complicated picture as we look backward. Then as we look forward, which is shown by the curve on the right, you'll see that, we're now looking at future conditions. In order for us to build infrastructure that's going to last a decade or more, we have to take future conditions into account. And so, once we get past this kind of current stage and we get out into the future, that's where large scale melting of continental glaciers could really have an impact. And that introduces a pretty fair amount of uncertainty into many of these projections. The one comment that I would make, and this goes back to the findings, some of the key findings in what is labeled here as Sweet et al. 2022. Some of you may think of it as the NOAA sea level rise projections, but really it's an interagency product with many federal agencies, including the Department of Defense, Army Corps of Engineers, USGS, all contributed to that document. But what's important here to kind of remember is what we're anticipating in terms of sea level rise in the next 30 years is an increase in sea level, mean sea level, equivalent to what we've seen in the last 100 years. So even though we're already manifesting problems at the coast, we can expect those conditions to become even more difficult as we go forward. So we're really at a key time here in terms of trying to develop a more resilient nation, a more resilient society, and a more resilient coastal zone. Next. So we have all this sea level rise going on. Obviously, that's part of a larger pattern of climate change. And at American Society of Civil Engineers, we really talk about this more in terms of changes in weather and climate extremes. Those extremes, those changes in extremes, changes in sea level over the last 40 years have become more and more apparent. But what we're also seeing is the systematic shift in increased losses due to a variety of natural disasters. This chart, produced by NOAA, just shows a histogram of $1 billion disasters in constant dollars. And so as you can see, from 1980, we've had a significant increase in losses due to natural disasters. A significant fraction of that are weather and climate extremes related. But I think what's important here to remember is, although there's definitely a climate signal here in terms of, changes in the patterns and the extremes of weather and climate, including changes in sea level, there's also a distinct pattern here in terms of what we build, where we build it, how we build it. And that's really become a major focus of the American Society of Civil Engineers. I'm very happy with the work EA is doing in this area as well, but obviously it's going to take a much broader effort to really address these issues. Next. So let's talk a little bit about the definition of nature-based solutions. Many of you have been around nature-based solutions. Maybe you think of it as ecosystem restoration or improving ecosystem function, but really what we've begun to talk about more and more is the notion of using nature-based approaches to try to address some of these resiliency issues. How do we make our systems more resilient, both the built environment and the natural environment? There's a lot of different definitions around. One we like here is actions that are designed to protect, sustainably manage, and restore natural or modified ecosystems while also providing benefits to people. Other entities might turn that around and talk about we want to have more resilient infrastructure, and we want to also develop or make sure that we have co-benefits that benefit ecosystems. Either way you look at it, this working definition kind of encompasses that. The other thing that became very clear to me when I was working on the National Climate Assessment and through my work here at EA is that the term nature-based solutions has a lot of different permutations. If you go north into Canada, they just refer to it as natural infrastructure. Other areas you might see it referred to as nature and nature-based features, or what's become ever more, I think, widely used or recognized is more of a green and gray-green hybrid infrastructure. These aren't just semantics issues. These actually kind of reflect a little bit of difference in thinking, in my opinion. For example, when we talk about natural infrastructure, we're usually talking about some actual modification, either naturally occurring or human engineered, that kind of changes the nature of the landscape. But actually what we're finding is we also want to use other, like if we want to just work with natural materials, we need to incorporate that into this kind of concept. And then finally, that hybrid system, I think, is something that really makes a lot of sense and is really driving a lot of the discussion. Is if we want to take credit for like flood reduction due to the management of natural lands, that's a natural, nature-based approach to providing a more resilient infrastructure to the built environment, which is immediately adjacent to it. So these concepts are all kind of evolving simultaneously. There's more and more effort to bring more coherence to this. That's a big part of what we're trying to do at ASCE, and we'll talk about that a little bit later. Next. So the other part that's kind of going on here, not only is there a bit of an evolution in terms of how we think of these terms and these processes, part of that kind of reflects the nature of the projects themselves and how they're beginning to evolve. If you go to New York and you talk to the sustainability office for New York City, they're going to, and talk about nature-based solutions, they're going to talk about rain gardens and green roofs and the types of structures and approaches that can be easily incorporated into the built environment. At the other end of the spectrum, I've been involved in work down in Louisiana for a couple decades. They're basically replumbing the Mississippi River Delta to try to address issues in terms of land loss, subsidence, a variety of different impacts. So the Gulf Coast, the projects tend to be more elaborate and more complicated. But many times we're really talking about, for the majority of the work in this space, they're kind of small scale ecosystem restoration projects like putting in a living shoreline, where you're trying to address a very specific problem at a very specific location. And it might involve tens of acres, but cumulatively, they provide additional resilience. And I think part of the challenge that we have to recognize is we have to go from these kind of small scale, regionally focused activities to larger scale, more systems approaches. And again, that's part of the discussion that I think dredge material fits into. Next. So, again, there's different types of projects, different types of approaches. Again, in this table, for example, which I believe is from the Army Corps Engineering Research and Development Center, you can have modification of the landscape itself, like the establishment or recreation, rebuilding of dunes and beaches. That kind of falls into the same categories like beach nourishment might be a project that you might think of in that category. Then you have more offshore modification where we're trying to restore wetlands or seagrass beds, trying to restore ecosystem function. But we also recognize that healthy marshes, healthy mangrove swamps reduce wave energy and therefore provide additional resilience to the built environment that may be onshore. We can also get into things like oyster and coral reefs. Those tend to have very specific environmental conditions in which they'll work. Water temperatures, salinities, for example, play a bigger role in where oyster reefs work well. Off the Louisiana coast, significant focus on barrier island maintenance and nourishment, because those barrier islands play such a big role. And then you get into the maritime forests and shrubs, again, the communities that live on land and how they provide additional benefits, both ecosystem benefits and additional resilience to adjacent structures. But most of these projects that you see here really take place in relatively warm climates, warm latitudes. We have to start thinking about how these projects could be executed in areas with high tidal ranges, or north of the Arctic Circle, where we have coastal erosion issues. We're trying to support the native Alaskan villages or other communities up in those areas. And these techniques are not going to translate very well. So we have to also expand our toolbox of approaches. Next. So, like many things, there's a lot of attention has been brought to this. We have this combination of we have these losses, these significant losses due to natural disasters. We have a desire to have a more resilient coastline and coastal communities. So this is, even though this work has been ongoing for many years, Biden administration recognizes the importance of trying to bring more of an integrated approach to the work we're doing for climate resilience. And so there's a White House initiative recently came out. As you can see, there's a link there to it. Came out last fall, that's really trying to accelerate the use of nature-based solutions or their incorporation into our thinking of how we respond to the climate challenge, including significant federal resources. Next. As I mentioned before, at the time that that initiative took off and the announcement of the additional funding was being put in place, there was actually now there's more and more guidance documents being promulgated. The White House put out a nature-based solutions resource guide that maps uh, tools and other kinds of information that are produced by many different federal agencies. One of those agencies, for example, is EPA. EPA has launched a Green Infrastructure Collaborative. You know, again, given EPA's role in environmental protection and kind of straddling that fence between the needs of humans and human society and the environment that supports us, it's logical that EPA would kind of lean into this and begin to explore how we can bring these different approaches into greater use. Next. Department of Defense is leaning into this heavily. As you know, Department of Defense manages huge amounts of land in the United States, especially in the coastal zone. So the U.S. Army is putting out a nature-based resilience activity. Department of Navy has as well. You know, these are going to be really important initiatives because they oftentimes anchor sections of the coast where, you know, there's not a lot of infrastructure around the base. Many times it's kind of undeveloped land. But those lands can be used as part of a larger strategy to provide resilience and protection, not just to DoD facilities, but other communities that may live in the area as well. So I like to think of these as kind of important touch points or anchor points to a broader strategy. And the DoD agencies and services have really stepped up in this regard. Next. Another part of this, of course, is funding and how funding works to support these projects. In order to really make these move forward and to go from kind of the conceptual design or the test pilot to a much larger scale set of activities, we have to find ways to encourage communities to participate. FEMA plays a big role in this area, for example. They've already leaned into this and are actively scoring projects and scoring proposals to support different kinds of projects in the coastal zone, for example, by incorporating or giving credit with additional points in their scoring system if you use nature-based solutions. And I think the BRIC program is going to be really key in helping a lot of coastal communities really kind of try to adopt these approaches into their mindset and their planning and construction to address climate change and sea level rise. Next. So here's just some examples of some other agency-specific guidance. On the far left is the FEMA Building Community Resilience with Nature-Based Solutions document. There's links for all of these, as you can see. The Department of Transportation, Federal Highways Administration is put out some guidance, and again, the Army Corps has as well. I think these are really important documents, but they also serve a different function in that you can see that, like, there's kind of a different flavor depending on what agency you're working with. And while this works very well when you're only dealing with a specific community that may only have ties to a specific federal program, those are pretty rare. And therefore, you know, more kind of a more unified approach is something that ASCE is beginning to recognize could really be useful in this space. Next. And part of that is being driven by the fact that all of this work and this work to develop a more resilient coastline isn't exclusively done by federal or state governments. There's a significant private sector interest here. If we can promote climate resilient communities, that reduces things like, the impact to the risk and reinsurance industry. It reduces risk for asset managers and holders of private property in these areas. As many of you know, some of these areas are some of the most expensive real estate in the United States. So it's not just a federal effort, it's not just a state effort. We're seeing more and more interest by private sector, for-profit and nonprofit organizations trying to come together to do a better job of reducing risk in these areas. Next. And so with that, I'm going to turn it over to my colleague, Chris Overcash.
All right. Yeah, thanks very much, Dan. So at this point, we wanted to really shift the focus of the conversation about nature-based solutions squarely onto the sediment considerations. And one very big driver of this dynamic is the Army Corps' beneficial use of dredge material program, which has moved recently to a 70% use of dredge sediment target by the year 2030, which is basically double what it has historically achieved. Besides Army Corps, there is a long list of state and other organizations executing dredging, many striving for increased beneficial use of sediment. And so the bottom line here is that dredge operations are always looking for places to place sediment, and we will learn in the next few slides about the increased need to obtain that sediment. Next slide, please. So also within the Army Corps envelope, the Engineering Research Development Center's Engineering with Nature program is at the forefront of understanding how sediment can be used. The Engineering with Nature program has been in existence for over 10 years and is one of the driving forces for harnessing natural processes to provide the resilience that will be needed as we move into an uncertain future. The program is looking to advance practices for all nature-based techniques, including those using sediment, and is executing applied research at sites nationwide. The key is finding sustainable ways to deliver these projects with a focus on collaboration in making sure the social, economic, and environmental goals are met. Next slide, please. So, but take a quick step back. Why is it so important to harness the power and dynamics of nature, including sediment use in these types of projects? So one of the answers lies in how much built infrastructure there is worldwide. In actually a study in the journal Nature in 2020 found that human-made mass of construction materials exceeded the total biomass of all the Earth for the first time in the 2014 to 2016 timeframe. So the upshot of that is there's not enough concrete, steel, and asphalt, etc., to build our way to resilience, even if we wanted to. Therefore, it is imperative to harness natural materials, including, of course, sediment and the natural processes to move us forward towards a resilient future. Next slide, please. Another key point in the story is understanding how effective nature-based solutions incorporating sediment can be compared to other more standard techniques. The figure here shows a benefit to cost ratio of different adaptation measures, in this case for Gulf Coast-based projects. The heights of the bars represent the benefit to cost ratio, and the width, the total benefit for each adaptation measure. And in the figure, the nature-based solutions are in blue. And as you can see from this, those NBS techniques are by and large more cost-effective than most of the traditional measures in their ability to avert damage. And this is just one example, not meant to be a holistic representation, but gives additional credence for nature-based solution use. Next slide, please. It is also important to understand some of the key drivers for the use of sediment. And one of the main ones can be explained by the what we like to call the do-nothing scenario for many intertidal systems, which is depicted on this slide. So specifically, certain habitat types will be lost if lateral migration is not possible due to the built environment as sea levels rise. In this case, the bulkhead in the center represents a blockage to migration of wetlands as rising waters impact this location. Sediment placement can be the solution for the marsh in question here, although obviously it's only going to pertain as a solution to a certain sea level rise level. All right, next slide, please. So the regulatory community's understanding of the predicament that we just explained, which causes loss of sediment, has allowed for the acceptance that we must learn more about how and when to use sediment as a nature-based solution. Because as we saw, the consequence of not doing anything is the loss of that marsh habitat over time due to sea level rise. So our team has been working with various regulatory communities, including going back to 2018, where we held a thin layer placement workshop in which a wide range of regulatory folks were in attendance to talk about solutions. And these types of discussions are helping to better understand how sediment placement can benefit ecosystems, and also, as counterpoint, what the drawbacks can be as well, and then ultimately how to find solutions to these challenges as we move into the future. Next slide, please. So because of these the recognized need to develop these solutions, our industry, including sediment owners, such as Army Corps and state agencies, research teams, including the Army's Research Development Center Engineering with Nature program, and academia, and consultants continue to learn and share information on how ecosystems can be improved, resilience can be achieved, and costs controlled to the greatest degree possible for the use of sediment as a nature-based solution. Case in point, on the top left, the Maryland Department of Transportation, Maryland Port Administration has had an innovative reuse, beneficial use of dredge material committee in place for over 20 years, which is identifying a wide range of opportunities to use sediment as a valuable commodity for future resilience. This has, in fact, included items such as procuring research-based efforts to explore new uses and opportunities for dredged materials in nature-based solution applications. Next slide. So over the years, as research has advanced and projects have been executed, it has become clear that the most effective implementation can only occur when the fundamentals of science and engineering merge, like they always need to in developing fields. In case in point, sometimes engineers now are being asked to mimic the dynamics of ecological systems that the scientific community themselves don't fully understand, which points again to the need for high levels of collaboration for these types of projects. So one very good example of this collaboration as presented on the slide is the American Society of Civil Engineers has an agreement with NOAA to pursue just such collaborative efforts to effectively merge the science and engineering to identify best solutions for climate-ready infrastructure, including those techniques which use sediment. Next slide, please. So we are also seeing a shift in current projects towards flood resilience and ecological need, which can be compared with older projects, which were just focused on finding a place for disposal of dredged sediment. This has been driven by the realization of both the value of dredged sediment and the pressing need to provide resilience to climate impacts. So projects like Popular Island Restoration in Chesapeake Bay in this photograph, which was initially begun in the early 2000s, was a pioneer in providing key ecological and resilience services, as well as a location for dredged sediment placement, and also was proof of concept of the co-benefit of merging these objectives. This dynamic is a fundamental change which is being instituted in current and developing projects using sediment as a nature-based solution. And the need to find a sediment placement site is now becoming secondary or even tertiary consideration in these ultimate designs. Next slide, please. So case in point, there are a variety of projects ongoing now that are focused on ecological and resilience benefits, as well as the need to ultimately utilize that dredged sediment. And these can range from pilot level projects, such as a dynamic revetment project in North Cove, Washington State, and Stone Harbor in New Jersey, which are depicted in the photographs on the left of the slide, to more research-based projects such as the NOAA Ecological Effects of Sea Level Rise grant-funded project seen on the bottom right, with project locations in both North Carolina and Florida, and then full-scale projects such as the Engineering with Nature Aberdeen Proving Ground project in Maryland, which our team is leading through the planning stages, and we're about to move to full design. And this particular project is slated to use large volumes of dredge sediment from the northern Chesapeake Bay area. Next slide, please. So other efforts are focused on trying to better understand the benefits and challenges in using sediment as a nature-based solution for projects. And one great example you can see depicted here on the slide is the 7 Mile Island Living Laboratory in New Jersey, which is a collaboration between the Army Corps and the state, which basically mimics a concept piloted in the Netherlands to test a variety of techniques for restoring marshes and providing resilience using sediment. This effort is providing valuable information to advance the use of sediment for a variety of nature-based solutions. And so at this point, I'm actually going to turn it over to Sam Whitten to continue the discussion on topics of advances in the field.
Thank you, Chris. Yeah, as Chris mentioned, I hope to talk a little bit about some forward-leaning type projects that utilize sediment or natural media in the immediate coastal space. And one of those projects relates to an effort we're supporting that's a NIFWIF-funded project and also a project that's funded by the Engineering with Nature program. It's located about 250 miles north of the Arctic Circle in Alaska. At this site, it's a community that's been in existence for several thousand years with a significant coastal erosion issue. And we're looking at the development of a dynamic revetment using locally sourced materials, as well as the development of a dune system to protect some of their historic sites. The unique thing about this project is the incorporation of indigenous knowledge into the design itself, which utilizes an ice cellar core to stabilize the center of the dune system, which also serves as a containment facility for some of the fish and whale and other meats that the community rely upon. So it's using thermosiphons and other forward-leaning technology to stabilize that core that ordinarily would not be used in a situation where the need was on its own. So this is the type of project that we're trying to evaluate the effectiveness of and to spread to other types of projects in the region. Next slide, please. Other forward-leaning projects, they're really being evaluated primarily by the Engineering with Nature program, and others within the federal government are such concepts as mud and sand motors. This particular graphic represents a project that was developed in the Netherlands, where essentially the dredge material is placed in a location where it naturally migrates to an area of need. And in this case, that's a coastal marsh system. So essentially the sediment is deposited, and then, as I mentioned, is naturally carried over to the marsh instead of having the direct placement of the material onto the marsh, where construction activities can sometimes damage that ecosystem. So understanding how these projects can move forward in other areas of the country, and in particular how the regulatory community might look at these projects is of utmost importance as we understand how sediment can be used as a nature-based solution. Next slide, please. So also to advance our understanding is really to understand what are some of the particular facets of use of sediment as a nature-based solution, and how those different facets are incorporated in the design process. Here on the left-hand side, you can see a summary of projects that were evaluated by the University of Georgia related to thin layer placement, where a number of different parameters were or were not monitored both before and after construction. You can see things like bulk density, organic matter, and nutrients, and the fact that not a lot of the projects evaluated those parameters. And one of the things we wanted to talk about today was really the need for folks to collect this type of data as they implement projects, because we are still learning an awful lot about how these projects can be successful. So for certain constituents like grain size, for instance, grain size is an extremely important parameter to understand during the design process, as it has a number of different implications as it's evaluated, specifically related to suspended solids and turbidity impacts, but also obviously contaminants, where coarser grain material holds less contaminants than finer grain due to a number of different reasons. But as I mentioned, we're still learning an awful lot about how these different parameters are utilized in the design process, and strongly encourage folks to monitor as much as they can during the development of their own projects. Next slide. This also relates to constructability issues. Obviously, we understand the fact that the bearing capacity of the marsh itself, if thin layer placement is the sediment or the type of project of choice. But in certain situations, the application of sediment might not even be possible within a certain marsh system due to bearing capacity. So it's another issue that we really need to better understand as we move forward when looking at the use of marshes as potential to use as improvements for coastal resilience. Next slide. So other factors that we're really trying to better understand as an architect and engineering community, but also as we work with regulators, is understanding what the impacts of habitat conversion are as we use sediment as a nature-based solution. Specifically, as we start to change elevation of certain systems and convert habitat types within the tidal frame. So we're talking about things like the conversion of essential fish habitat, or even impacts to submerged aquatic vegetation areas, and bringing those up in elevation to the point where they might be either high marsh habitat or similar. So what are the values that we're placing on those different habitat types, and is the conversion acceptable to all those involved? And more than likely the answer is no, that it's not going to be acceptable to everyone involved, but the idea that we need to have these conversations is very important. Especially as we look at different timescales. We're really concerned about the fact that we know that if we design for certain situations over the next 5 to 10 years, that habitat type is going to change as sea level rise occurs. So having those conversations and being able to fully understand what the habitat conversion potential of the site is going to be is very important for these projects. Next slide. Also, as I previously hinted to, is the impact of suspended solids and turbidity on the surrounding project site. Obviously, folks that are involved in dredging projects know that the minimization of turbidity during a project is very important. And it's also important during the placement of sediment in these projects as well. Unfortunately, there really doesn't seem to be a way to completely eliminate the turbidity that occurs as a result of some of these projects. So again, just like with the discussions that need to occur related to habitat conversion, we need to have an understanding of what the true impacts in the short and long term are to some of these receptors resulting from impacts from suspended solids. So again, we all know that during storm events that there's naturally occurring suspended solids that impact certain bottom habitat types. So does the temporary impact of these projects mimic those temporary impacts as a result of storm events? So again, I certainly don't have the answer to these questions, but it's important to continue to have the conversation relating to these impacts. So next slide. Another impact or another aspect of design that both Chris and Dan hinted at it was the need to take non-stationarity into account. And by non-stationarity, we really mean changing climate. And by that, we really need to make sure that we're designing forwards and not backwards. Obviously, the figure on the left here is a situation that would never be allowed. Having a house built on a marsh platform, not just due to the impacts to the ecosystem and to the infrastructure today, but also what that means, what that structure would look like after 50 years of sea level rise. So we need to take those same issues into account when we're thinking about natural systems into the future. We need to design forward and not backwards. This really impacts the idea of ecosystem restoration, because we can't restore back to what used to be there, because that climatic condition isn't going to exist into the future. So the whole way of thinking needs to change a little bit when we're talking about the use of sediment as a nature-based solution. And again, it's not unique just to sediment, but it's also unique to ecosystem restoration as a whole, that we need to really change our thinking and how these projects are executed. Next slide. So starting to wrap up here, talking about funding, I think that most of the folks on this webinar will appreciate the fact that funding is at unprecedented levels right now for a number of different reasons. Obviously, some of the federal funding that exists is tied directly to the improvement of natural systems and improving their ability to address a changing climate. But also there's an awful lot of funding that's out there to promote construction and the engineering industry. So I think it's very important for all of us to take a step back and to see what is available both now and into the future. A great place to start, I think, is the National Wildlife Federation website, which summarizes federal funding that's available for nature-based solutions in the coastal space. The Department of Transportation, Federal Highway Administration just came out with a significant amount of funding for nature-based solutions that affect transportation projects. And then obviously entities like NOAA and the National Fish and Wildlife Foundation, which utilizes federal funds, are also key in supporting these types of projects. So that's just a summary of some of the federal funds that are available. Next slide. State and local, a lot of state and local entities obviously use federal funding at their core, but they also are funded by other tax and other funding sources. So this is just a quick snapshot of some of the funds that are available in the Great Lakes area, Florida, Massachusetts, and the Mid-Atlantic within Maryland. So again, some great dashboards depending on where you are. And again, based on the folks that are attending this webinar, which are from all over the country, we didn't want to focus on one state and local area. But obviously, the web is a great source to find these funding sources. So I'd encourage folks to take a look in at their own state resources as you look for matching funds, which aren't always required anymore for federal dollars. But there's again a lot of funding at the state and local level. Next slide. And as I mentioned before, an awful lot of federal and state funding will move through certain nonprofit entities, a series of these here on the left. But also it's important to look at nonprofit and academia partners as you look to develop projects as well. These entities can bring a wealth of technical knowledge to support your projects, but obviously also some additional funding as well. So having a nonprofit or an academic partner for projects specifically where we're still trying to learn, how some of these projects might effectively be implemented is an important aspect because there are an awful lot of research needs as well. Next slide. And then finally, I encourage folks to think about other types of funding that may not immediately come to mind. And one of those areas is blue carbon. Specifically, as we look at tidal and wetland restoration in the coastal space, those types of habitat types do have the ability to sequester additional carbon above what might currently exist in that area. There is funding both at the federal and the government level for these types of projects, but also, as you can imagine, relating to blue carbon trading and carbon sequestration investments by different entities. So I would encourage folks to kind of think outside the box a little bit on those as they look for funding streams to support their projects. I think blue carbon in particular is an expanding field, but also one that we're trying to understand how effective it's going to be as well. So again, there's some research aspects to this as well. So next slide. So in conclusion, wanted to thank everybody for sure and pass this on to Amy in a second, but I would encourage everybody that's on this webinar to continue talking. As you've heard numerous times on this presentation, there's an awful lot of learning that still needs to be done. I think that may not ever stop happening. I think that the ecosystems and the systems that we're working with are so unique that and so dynamic that we'll never be able to say with 100% certainty that any sort of nature-based solution in a particular area is going to work for sure. So I would encourage engineers to reach out to scientists, natural resource scientists, and vice versa, because without the coordination between both engineers and scientists, we're not going to be able to effectively implement these projects. So I want to give a shout out for an engineering conference coming up. The ASC Inspire conference is coming up in November. where we hope to have additional conversations about this topic. And then on the flip side, from the scientific perspective, the Coastal Industry and Research Federation, their conference in November as well, related to resilience and recovery. I think it's important for engineers to attend the estuarine conference and vice versa, scientists to attend Inspire. So again, I just want to leave folks with that additional thought, to keep reaching out across the aisle to either the scientific or engineering community to try to move some of these really innovative projects forward. Amy?
Thanks, Sam, and thank you, Chris and Dan. That was a great presentation. I'm sure there are several people with questions out there. Here we go. What's one of the biggest challenges for implementing or designing nature-based solution projects? Which one of you wants to take that? Sam?
Sure. I would say, is uncertainty, and mostly related to the understanding of the existing system. That these are such complex systems, both from an ecological standpoint, a physical standpoint, and then you throw climate change on top of that. You've got additional uncertainty with that. So I think that, combined with the fact that this, there has obviously been ecosystem restoration projects for many years, but it hasn't really received the funding and the attention that we would have liked to build up that scientific and engineering knowledge that would kind of give us a little bit better place to start from right now. That's certainly not to say that we're starting from zero. I don't want to suggest that at all, that there is no knowledge base, but I would say that as compared to certain other fields, the use of nature-based solutions to improve resilience is somewhat developing. And again, that is tied to the fact that we are finally seeing some increased funding levels. Somewhat related to that is, again, something I mentioned at the end, which is these projects really require the very close cooperation of the scientific, natural resource community and engineers. Typically, projects in this space have been developed by engineers, and then scientists have been brought on for permitting issues and things like that, and they've really been done in silos. So this is a change in that those scientists need to be involved in all aspects of the projects to understand the nature-based portion of the nature-based solution to make sure that functions. So it goes beyond really just kind of the permitting requirements and starts to integrate these natural processes into the basis of design itself. So I think that's a little bit different for both the scientific and engineering communities to execute. So those are probably the two primary challenges that I would have to say, is just that we're still learning a lot. And then also, just from a process standpoint, both the engineering and science communities are still working things out.
Thanks, Sam. Next question. Is there funding for communities along eroding rivers that aren't close to the ocean?
I could take that's an easy, quick yes.
Go for it.
Yeah, I mean, we certainly focused on use of sediment in the coastal space, nature-based solutions in the coastal space during this presentation, but that's just based on some of the work that this small group within EA has done, and we've, as a company, done a lot more within riverine systems. But essentially, almost every program that we spoke about, minus I think the National Coastal Resilience Fund and a couple others that NIFWIF executes and NOAA, there's a tremendous amount of funding for inland river communities. Didn't really touch a lot on the Great Lakes, but those are really considered coastal by a lot of federal and state and local partners. So they get coastal funding, even though they're the Great Lakes. But as far as riverine funding, there's a tremendous amount. And again, if you want to reach out to me or any one of the other speakers, be happy to kind of just direct you to where some of those funding sources may exist.
Thanks. Next question, probably for Chris. Could you expand more on the source of the sediment planned for the Aberdeen project?
Sure. Yeah, to jump on that question. So right now we're actually still in the planning, maybe 10 to 15% level design for opportunities there. So there's been some open discussions with Army Corps. There are several channels in the northern Chesapeake Bay that are dredged regularly to the tune of about 1.2 million cubic yards of sediment per year. But ultimately, we wouldn't need that material to probably 2025, 26. So again, it's just initial discussions. Besides the main channel, there's some auxiliary channels running from the main channel to Havre de Grace in a few communities that dredge on a non-regular basis that could be potential sources.
Thanks, Chris. All right, I'm going to direct this one to Dan. Any observations on how academia is responding to the need for more professionals in the resilience, climate change, adaptation, and infrastructure engineering space? And same question for industry associations.
Well, I mean, that's a great question. I think what we're seeing at ASCE certainly is really kind of needs on a couple different levels. Many of the civil engineering students that come out of school today are far more versed in the science of climate change than maybe their predecessors 10 or 15 years ago. You know, if you've gotten a civil engineering degree, you know it's a very crowded curriculum. You know, if you're going to add a class that focuses more on some of these issues, you know, you're going to have to make room by maybe dropping a class. That's, you know, when it comes to that, academics can be very, very conservative. But what we're seeing is more of a trend where these issues are being injected into the actual course material of some of the more traditional core courses. ASCE is I've also recognized that many times it's a little bit maybe the next older generation of engineers that are very much used to working and thinking about these projects in terms of a non-stationary or a stationary environment. And so, you know, we have to kind of retool the thinking of some of the program managers or project managers at more senior levels to help them understand the dynamic and to encourage their younger employees to either use the skill sets that they picked up in school or develop new tool sets, skill sets. So that's ASCE's putting a big focus on that. I'm involved in a series of webinars through ASCE that are focusing on those kinds of issues. I would say that in general, the space around flood risk is probably a little bit farther along, maybe less mature is research going into changes in climate and its impact on wind and wind fields. And then we have some other aspects, other traditional loading areas like snow load, rain on snow load, this whole compound issue where honestly that work really needs to advance and we need to get that guidance out into the community more quickly. And that's ASCE has just released in 2022 a new strategic plan that puts a much greater focus on updating codes and standards, updating guidance documents, and in kind of developing a more relevant educational content for both the emerging engineers and the practicing engineers that are involved, going to be more and more involved in these projects.
Just a quick addition to that on my role as Johns Hopkins program manager, we're actually about to launch a new master's program titled Climate, Energy, and Environmental Sustainability because of the recognized need in industry.
Next question, how do you get buy-in from NOAA or U.S. Fish and Wildlife Service when either listed species or EFH may be impacted by your project?
Well, we only have 2 minutes remaining, so I'll have to speak quickly to this. But I mean, you know, bottom line answer is obviously that it's certainly project and location dependent. But to try to give you you know, what we've seen is it's going back to something that Chris had mentioned in one of his slides, and that's the do nothing, you know, alternative, specifically in areas where again, marsh migration or lateral migration of that intertidal habitat type isn't possible. If you look at the do nothing, and if the do nothing also directly, you know, impacts negatively, you know, your EFH, your T&E species, then it's the same, you know, end results as if you're going to temporarily convert it. So looking at kind of the bigger picture, the bigger watershed, you know, is there marsh migration that's possible or lateral migration that's possible elsewhere? And so, you know, understanding what that do nothing approach is going to, you know, do to those same receptors, and having that conversation beyond just what's going to be there tomorrow, but what's going to be there in 10 years, what's going to be there in 50 years. So if your project is going to convert that habitat type and impact EFH or T&E species, you know, looking at how long that's going to last. Is it going to last, you know, is there going to be 100 years where it's going to benefit those species? And that the temporary impact is only going to be over a couple of year period. So I think it's the incorporation of that do nothing is the best way to try to convince your Fish and Wildlife and NOAA folks that this might be a good project. And I know that doesn't cover all scenarios, but that's what we found is effective is approaching it that way.
All right, well, it's just about 3 o'clock, so we're going to wrap that up. That was our last question. As you can see, I've shared Sam, Chris's, and Dan's contact information. If you have additional questions, you can feel free to reach out for them. And thank you so much for joining us, and we hope to see you at our next session on PFAS. Have a good day.